Hi folks, we're approaching Easter, so when it finally comes, happy Easter. I hope you have a lot of chocolate eggs. I know I will be doing. I just want to give you a little bit of work to do throughout Easter. This is really quite short work, but also give you opportunity to catch up if you're not quite finished with everything else. I just want to keep the momentum going because we are anticipating you will have to take your exams in the summer, so we just need to do a little bit every week just to keep you going. Okay, so let's look at what we're doing in this one. So like I said, it is a short task this week. We're going to compare fractions and then express probability as a likelihood and as a fraction. So I'm wrapping up fractions basically. Let's do the first one, which is actually a calculator question. I've taken this one from a sample test, but I've changed the fractions. The question is, which of these fractions is the biggest number? You might be just really good at looking at fractions and knowing which is the biggest number, but if you're not, this is a calculator question. So if you want to use your calculator, we need to put all these fractions into a number, and actually we're going to do that by making it a decimal number. So to do that, we take the top number and we divide it by the bottom. So 6 divided by 10 is 0.6. Now 2 divided by 3 is a bit of a funny one, because when you get that one, you will get 0 and it will just go on and on and on and on and on. On some calculators, eventually you'll get a 7 at the end, but actually it's 0.6 recurring, so it's just 0.6. 3 divided by 8 is 0.37. Oh, sorry, can I just rewrite that one? I just want to line it up a little bit better. There we go. 0.375. And last but not least, 1 divided by 2, which I would hope you know, is 0.5. So now we need to know, well, which of these is the biggest number. So now if we're looking at these numbers, they all start with 0 point, so we're just kind of going to ignore the 0 because they're all the same, and then we're going to have to look up along or look down along this column. So we've got a 6, a 6, a 3 and a 5. Well, if we're looking for the biggest number, in this case, 3 and the 5 are both smaller than 6, so they're out. Now we just need to decide which one is bigger. Is it 0.6 or 0.6666? To make the top one 0.6 to look like the others, we could just add some zeros. And now if we compare the next column along, the 6 is obviously bigger than 0, so actually 0.6 recurring is the biggest number, which means that out of all of these, 2/3 is the biggest fraction. So just to summarise, top number divided by the bottom, and then you're comparing which is the biggest number. Or in your exam it could be which is the smallest number. Just make sure you read what they're asking for. And that's the end of that one. Now we're going to move on to our second objective, which is probability. You've got to do answer questions on likelihood. So see at the bottom here, impossible, unlikely, even chance, likely, certain. Let's take a look at the question. A company states on its website that orders placed before 11 a.m. should be delivered the next day. Most customers place their orders before 11 a.m. So that should tell us that actually most customers will get their orders delivered by the next day. What is the likelihood a customer will receive their order by the next day? So we've already established that most of them will. So look at our choices. It's going to be towards the upper end of this scale. So it's either likely that they will, or it's absolutely certain that they will. In this case, it says that they should be delivered by the next day, so it's not an absolute certainty. So in this case it is likely that it will. And the last probability example, this is actually taken from a sample test, and I've changed the wording slightly. A fair has a spin the arrow game. Here is the spin the arrow on the right hand side. A person wins a prize if the arrow lands on a 2. What is the probability of a player winning a prize? Write your answer in its simplest form. So the fact that it says write in the simplest form actually means we're going to write it as a fraction. So first of all, how many times do we see the number 2 on this spinning board? So we've got 1 here and we've got 1 here. So actually only there's 2. So there are 2 chances. There are 2 chances for the arrow to land on the number 2. But now we need to know, well, how many opportunities are there? And that just means, how many places are there on the board? So let's just count them up. I'm just going to do them as I go along. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 in total. So this looks like a fraction now. So basically 2 out of 12 chances. Thing is though, this fraction here actually says in its simplest form, so that should tell you that you need to make this fraction into its simplest form. They're both divisible by 2, so the top one divided by 2 will give you 1, and the bottom number 12 divided by 2 will give you 6. So the final answer is there's a 1 in 6 chance that the arrow will land on the number 2. This question was worth 2 marks because you get 1 mark for getting your first fraction, and then you get another mark for simplifying it down. That is the end of this tutorial, so I'm going to put a short activity on just to answer some questions like that. And remember, if you haven't done so far, I need you to catch up, but also look back at your feedback when I've been marking. I may have given you follow-up questions or asked you some questions. Okay, thank you and have a good Easter.